All right, let's take a look at another example. Here you're given another quadratic equation to solve, and we want to walk through that four-step procedure again. Remember, what's the first step? The first step is to make sure that your quadratic is in, that's right, standard form. If the equation is already in standard form, there's nothing to do with it. You can move immediately to step 2. But always check. It's very easy to make silly mistakes and then end up with incorrect answers. We have to ask ourselves, is this equation in standard form? Yes, it is, right? 0 is on one side, everything else is on the other, and the exponents get smaller and smaller on the variable. In this case, the variable is x, as we move from left to right. X to the second, x to the first, and no x's. Step 2, identify the values of a, b, and c. It's pretty much a straight shot if you have the equation in standard form. A will be on x squared, b will be on the regular x term sandwiched in between these two ends, and c will be the number without the letter, the constant term. So a is going to be...
Hey, that's great.
Isn't it though? A is going to be 1, b is going to be 3, and c is going to be 2. We can now move to step 3, and we're going to replace the letters in the quadratic formula with their corresponding values and simplify. We just saw from the previous slide that a is 1, b is 3, c is 2. And now we're going to begin to replace those letters inside the formula with their corresponding values. Please remember that whatever b is from the quadratic equation, its sign is going to flip in the quadratic formula, right? So b is positive 3 in the equation, but when it's plugged into the formula because of this minus, it takes the opposite of whatever b is. This positive 3 is now a negative 3. Remember that the square root symbol is also a grouping symbol, so we have to take care of the stuff inside of it. Really, before we can do anything else, this is going to be 9, this 4 times 1 times 2 is going to be 8, 9 minus 8 is 1, and then on the bottom 2 times 1 is 2. And notice that 1 is a perfect square. The square root of 1 is 1, because 1 times 1 is 1. So we can take the square root of 1, and upon doing that, we get ordinary old 1. Please, please, please do not keep the 1 where my cursor is in the square root at this point. It's served its purpose. The square root has served its purpose. The square root of 1 is regular 1. The square root of 1 is regular 1. We've used the square root. It served its purpose. We no longer need it. And now we're going to break this equation at the bottom up into 2 pieces, which is our step 4. And we get 2 pieces on account of this plus minus here, in between the negative 3 and the 1. We have negative 3 plus 1 over 2, and we're going to have negative 3 minus 1 over 2. So if we break those up into 2 separate pieces, simplify, negative 2 divided by 2 is negative 1, negative 3 minus 1 is negative 4.